it's frozen. Hold on. I hate like everyone all settled, and then I have to go back. Standard form. Thank you very much.
Did you hit record on the
I guess it still says my test. So 30 seconds of no. The first step is to get it in standard form. And so that means you want all the x's and y's on one side and the constants on the other. So in the first example, that means moving 2x over to the left. And that would give me negative 2x plus 6y equals 4. And for the second equation, it would involve moving the y over by doing the opposite to both sides, and the 14 over by subtracting it from both sides. And so what that would give you is this, 7x minus 21y equals negative 14. And the benefit of the standard form is when the x's and y's are all stacked up, because you're about to add them, it's just easier to see how they compare to each other, because you want to make their coefficients the same. And then when we go to add vertically, it's just easier if like terms are stacked above each other. So you can eliminate either variable that you want. Who eliminated the x's? And anybody eliminate the y's? It doesn't matter what you do. They both already have what's going for them that's good. We're trying to get them to eliminate, cancel out. They already have opposite signs, both of them. Okay, so even then it really doesn't matter which one you pick. I'm going to go with the x's. So then I got to multiply both of these equations by whatever numbers are necessary to get the coefficients to cancel out. So what can I multiply 2 by and 7 by? It can be different numbers so that they have the same number out front. What do you like for the top one? And we're at the bottom. Why do you think I didn't include negatives in the 7? They already have opposite signs. You could make them both negative, that's fine, as long as they're both negative. So if they were both negative, it would change, make this positive and that negative, which is fine. So then this gives me negative 14x. No, okay. All right, so 22y equals 28. Multiplying 2 through on the second one. I'm trying really hard not to say this. I'm reading it again, that was making me up. Okay. So then when I go to add these, what happens? I was trying to cancel out the x's. That happened. But what else happened? They all cancel. Which gives me 0 equals 0. So here's what happens when all the variables cancel. And you get some number equals some number. You ask yourself, is that true or false? And what would yourself say? It's true. So if you get something that's true, how many solutions does this system have? It could be many. That means that no matter what numbers you plug in for x and y, they'll check out and it will be true. So really, what's true about these two lines? Do they intersect? Are they parallel? Or are they the same line? Same line. And we have, what word do we have for that? Okay, dependent, independent, consistent. I don't know what they call it. I don't care about that. I'm not going to do it. I think it's dependent. On your quiz tomorrow, we will have problems that say, they'll say, identify whether it's independent, dependent, consistent. Who's looking? Anyone have a note? But even if you can't remember what that means like me, it's okay, because we have in parentheses what it means. So it'll say dependent, and parentheses will say infinitely many solutions. You don't actually have to. I can remember. So this was about elimination from yesterday. Did anybody get to the homework for yesterday, the elimination one? There's some really good problems in there, some really challenging ones in there with fractions and stuff. It's good for you. It puts hair on your math chest. It makes you stronger. Right. So here's what we're going to do today. You have your papers, right? We're not learning any new methods. What we're going to do is word problems. We're going to set them up, a system of equations, and then we'll use these methods to solve. What I want you to do right now is, first of all, be sure you have the right papers to look at to begin. You need the half sheet with the steps. And then you want the sheet where Miss Arnold wrote notes in the upper corner with her own handwriting. We have this jeweler who, I can't say it, so I have to say it real slow. Because I can't say it. Kind of like my last name, I have to like fake it. I can't. Anyway, for 22 years I've been thinking how to say my married name. But anyway, so a jeweler, a person named Jules, is commissioned to create a piece of artwork that weighs this much, 14 ounces, and has 75% gold. Okay. So she goes, she's like, all right, I can do that. She goes to look at her supply warehouse. And she sees that she has 2 gold alloys. Are you familiar with that term, alloy? It's like a blend, right? It's not a pure substance, it's a blend of things. And she has these 2 alloys. One, 60% of it is gold, and the other one is 80% gold. So sadly, she doesn't have one that's exactly 75% gold, because that would be easy, and then we wouldn't have a word problem. She's got to figure out at what ratio she needs to mix those 2 to hit P specification. So our goal is to first read the problem and identify what is asked for. We read it. What is the problem asking us to find exactly? How much of each alloy she needs, right? Okay. So we're going to just start there. I'm just going to start writing some down. How much, and there's how many alloys too, right? How much of the 60% alloy, and how much of the 80%? But what specifically about that? How much, what about it? To make 75, but what about it is going to be making the 75? It's height, it's length, it's weight, it's weight. Okay? So when I say that, how much of the 60% alloy do we need, or the 80%? I mean, how many ounces? So see how I'm already going to sort of modify what I've written here? It's not just how much, it's the weight. How many ounces? That's what we mean by how much. This is a weight issue right here. We want to know how much of each by weight. The 60% just means whatever its weight is, 60% of that is gold. A portion of its weight is gold. All right, so that's fine. We read the problem, we identified what it's asking us for. Step 2 is to define the variables to identify the quantities needed to solve the problem. So we don't know how much we need of these, and anytime we don't know something, we put a variable on. So let's do that here. We're going to call the 60% alloy X and the 80% alloy W. I said W, I wrote Y. I meant Y. Sorry. I'm bringing because the one doesn't matter. All right. So X, Y. What our job is to do now is to make equations that relate X and Y to each other, that incorporate this information, the 14 ounces and the 75 ounces. That's what number 3 says. Write equations to model the situation. Remember, the number or variables must be the same as the number of equations. So if I have 2 variables, how many equations am I going to need? 2. Very good. All right. And then step 4 is to solve. So let's figure out how to set up the system. We can use whatever math operations we know to relate these things to each other. Maybe we have to add them, subtract them, multiply, divide, or whatever. I've kind of already given you a clue here, and it's this word weight. X stands for the weight of this alloy. Y stands for the weight of this one. Well, what do we know about their weight together? They have to equal 14, right? What does that mean when I say how much of them together they have to equal 14? Yeah, absolutely. Okay, make X plus Y added up has to equal 14 ounces. You all right about that? That's true, right? The percent of the final product, the percent of that 14 ounces has to be 75. So now we need an equation. So we made our equation that handles this weight information, and now we need one that handles the percent. This is going to use the 60%, the 80%. And to sort of guide you into this equation, I have this question. This is a side question. Or the problem that's not, the number that I'm going to use that's not in the problem. If I told you that I had 12 ounces of the 60% alloy, and I wanted to know how much gold was in there, what math would you do? 12 ounces of 60% alloy. How much gold do you need? This is a side question. Okay. 60% of this is gold. So how much gold is in there? How many ounces of gold? What math would you do? Which math operation? That word of in mathematics, almost every time you use it in a word problem, it means multiply. So 12 ounces of 60%, or 60% of that 12. Right? You take the percent, you convert it to a decimal, which we always do before we do math. 0.6 times 12, because that will give you the portion of the 12. That's the goal, right? Okay. The reason why I did that is because now I'm about to put the variable back in, but that won't make sense to you if you don't understand this basic idea of computing a percentage of the total. So then going back over here to this equation about the percentages. In this case, I knew that I had 12 ounces, and it was 60% of that. Over here, I don't know it. I'm trying to find it. But the math is still the same. 60% of whatever the weight is. Still multiplication. And I need Y amount of the 80% alloy. So this represents how much gold is in the X amount final weight. This represents 80% of the final weight in that alloy. All of that together, our final product, 75% gold, right? It's not just 0.75 over there. It's the percentage of your final product, that amount. So it's 0.75 of how much? 14. So now we have a system of equations. And I want you to take a few minutes to solve this. You can use either substitution or elimination, whichever you like. Technically, you could use graphing, but I didn't give you a graph. So take a few minutes. No, we have to 35.
Hey, yeah, I got your copy.
Yes, and those are going to be in little five. You should have had 3.5 and 10.5. So sorry.